Saturn is famous for its extraordinary ring system, which is made up of countless icy particles and debris ranging in size from micrometers to meters. These rings are composed mostly of ice particles with traces of rocky material, and they extend thousands of kilometers away from the planet. Saturn has multiple distinct rings categorized into different groups. The main rings, labeled A, B, and C, are separated by gaps known as Cassini division. Additionally, there are fainter rings named D, E, F, G, and others, each with its unique characteristics. Despite their sheer size, Saturn's rings are remarkably thin. The average thickness of the main rings is around 10 to 30 meters, while the thinnest parts are as thin as a few meters, making them incredibly delicate compared to their expansive breadth. Scientists believe that the rings of Saturn formed from the remnants of comets, asteroids, or moons that were shattered by impacts or tidal forces. The icy particles in the rings are thought to be composed mostly of water ice, along with some other compounds like methane and ammonia. Saturn's rings are influenced by small moons called shepherd moons, which help maintain the shape and structure of the rings. These moons orbit near the edges of certain ring segments and their gravitational pull interacts with the ring particles, keeping them in line. Spiral density waves can be observed in Saturn's rings. These wave patterns are caused by the gravitational interactions between the planet and the ring particles. They create stunning spiral patterns, enhancing the overall beauty of the ring system. Saturn's rings are not static, they are constantly changing. New ringlets can form, while others may disperse or merge over time. These variations in the ring system can occur due to gravitational interactions with moons or the influence of Saturn's magnetic field. As sunlight passes through Saturn's rings, it creates intricate patterns of light and shadow on the planet's surface. These shadowy imprints are cast by the rings and their gaps, producing an ever-changing spectacle of celestial art. Despite extensive research, scientists are still unraveling the exact mechanisms behind the formation and composition of Saturn's rings. Studying these rings provides valuable insights into the processes that shape our solar system and its celestial bodies. The Cassini spacecraft, a NASA mission launched in 1997, provided us with an unprecedented close-up view of Saturn and its rings. The mission ended in 2017 with a dramatic plunge into Saturn's atmosphere, ensuring the protection of Saturn's moons, but leaving behind a wealth of data and stunning images for scientists to continue studying for years to come. Saturn's captivating rings continue to amaze and inspire us, offering a window into the wonders of our cosmic neighborhood. Their enigmatic nature and ever-changing beauty make them a subject of endless fascination and exploration.